Hi guys, welcome to another chemical engineering tutorial brought to you by the ChemEng student. In this lesson we're going to take a look at the method of integration by parts. Now this type of technique is incredibly useful for us as chemical engineers in terms of some analysis. So this forms part of our engineering mathematics course, which I'll put a link in the description that you can check out at a later date. So the integration by parts is essentially the opposite to the product rule that we've seen in differentiation. Now, integration by parts is applicable to systems where the actual basic or linear integration process becomes too complex and it's in need of some simplification prior to carrying out the full integration. So this can often be quite time consuming. Now, one way that we can check if we need to apply the integration by parts is when we look at our new integral, when we combine the different functions, if it becomes more complex than the one that we started with, then the chances are we should have used integration by parts. Now, there are two ways of representing the integration by parts formula. Now, both mean exactly the same thing, and it is just down to your personal preference. But the first general formula looks something like this. So we have two functions, so f of x and g of x. Now, the integration by parts means that we have f of x and g dash of x. So this is the differentiated function of g of x. Now, the formula for the integration by parts would be that we multiply the standard integrals, so we have f of x and g of x, minus the integral of the differentiated f of x function multiplied by the standard g of x function. Another way that we can represent this that can sometimes be a bit easier to see is that we use u and v. So what we say here is that u is f of x and v is g of x. So this would be u multiplied by dv by dx, because that is the differentiated term of v, and this is of course with respect to x. Then we have u multiplied by v minus, then it will be v multiplied by du by dx, or du by dx multiplied by v, exactly the same thing. And this is with, again, respect to dx. So these are the two general formulas, and whatever one you use is just down to your personal preference. Now, defining u and v, or f of x and g of x, at the beginning is essentially down to your discretion. You can decide as to which one, for the equation that you're wanting to solve, you can choose what one is u and what one is v. However, it is often easier to try and stick to the same convention within your equation. So try and make life easy for yourself. Look at the easiest possible one, i.e. to differentiate, and then further integrate. So again, this just comes down as well to experience. So after you've done several different examples, you should be able to identify what the easiest path would be. Sometimes there isn't an easy path, it's just one is more simpler than the other, but the overall system is fairly complicated. Now, the best way to look at this is by an example. So we're going to look at this definite integral, and we need to find the exact solution. Now, the reason we can find the exact solution is because we have limits here. So we have the equation, the integral of 0 and 2 and x plus 1 bracket x minus 2 cubed dx. So the first thing that we need to do when we do integration by parts is identify the u and the v terms. So what we will say here is we will take the first term, so the x plus 1, we will identify this as u. And then we will identify the x minus 2 cubed. Now this isn't directly v just yet. This is dv by dx, because remember, this we are assuming is a differentiated form of v. So what we then have to do is when we define each of them, we will differentiate and integrate them respectively in order to achieve the four variables, because as it stands just now, we have u and we have dv by dx. What we don't know is we don't know what v is, and we don't know what du by dx is. So the first thing that we can do is differentiate u. So when we go to differentiate this, we just remember that this is to the power 1, and then we have dv by dx, which we will therefore have to integrate in order to get v. So when we differentiate this, we differentiate that x to the power 1 will become 1, and 1, when we don't have an x, will differentiate and it will disappear. So we know that du by dx is 1. Now for dv by dx, what we will do is we will integrate this system. So what we will do is we will increase 1 to the power. We will divide by the new power, so we end up with 1 over 4 x minus 2 to the power 4. So now we have all 4 of the variables required in order to solve this system. So this is just a summary of the terms, and now what we will do is we'll take this, our general equation, and we will then begin to substitute in the values of u, v and du by dx. So in doing so, what we then say is we have this system here. Now the one thing that you must remember is although this doesn't have this is outside the integral, we still have to substitute in the correct values of the limits when we substitute in these values of the limits to this equation. So the key thing here is that v and du by dx is essentially going to just be v, because du by dx is 1. So when we multiply v by when we multiply v by du by dx, that's just going to give us v. So we now just have to integrate this equation. So in doing so, we end up with 1 over 20 x minus 2 to the power 5. Because remember, we increase the power by 1, we divide by the new power, so that would be divided by 5. So 4 times 5 would give us the 20, and then we get the new power of 5. Now from this, all we now have to do is substitute in the correct values of the limits to x, and then collect all the terms and simplify where possible. So in doing so, we will substitute in the values of 2 in here. So we'll do 2, then as always minus, so we do the top limit minus the bottom. So here we've substituted in 2, minus, we've substituted in 0, then this minus is this minus in here, and then we do the exact same thing. We'll substitute in 2 first, then we'll minus, and we'll substitute in 0 second. So then, what we'll do is we will start to collect all these terms, we will begin to simplify, and we can see that the exact solution for this integral with these given limits is minus 28.5. Now what you could do is you can try this question yourself and see if you can get the general formula using integration by parts. Try and define your u, define your v, and then substitute into the general formula and make sure that you can obtain this equation here. So that is the general solution for this integral. And remember, just use the process that we've seen in the previous example and you should get this answer. Let us know in the comments if you did get this answer. If you didn't, then please feel free to get in touch and we can show you exactly how to solve this step by step. So that's the end of this lesson. Thanks for watching. Hopefully this was helpful in understanding the concept of integration by parts. If you liked this video, please like and subscribe to the channel. It really helps us reach as many chemical engineering students as possible. Thank you for your time, and we hope to see you in another video.